This video is going to demonstrate three corollaries of the transverse parallel theorem. Essentially, the first thing we have to do is identify the pieces that we're looking at. The two blue lines are parallel. We know that because they're indicated by the arrows. The green line is called a transversal. A transversal cuts across any system. When this transversal cuts across this blue line, it creates an angle of 55 degrees. Why? Well, it's just an angle that we're using to demonstrate the theorem. Now, the theorem is in three parts. The first is that if we have a pair of angles that are on the same side of the transversal and contained within the two parallel lines, like this 55 degrees and this angle, we'll call it A, then we know that the sum of those two angles is supplementary. That is, it adds to 180 degrees. We know this because if we think about translating this part of that C shape up, it would create a supplementary line. You can see just moving that to there, you would have a straight line and therefore 180 degrees. So we can write the statement that 55 degrees plus A is equal to 180 degrees. And we write that it's by the transverse parallel theorem co-interior. Because of co-interior angles. The next theorem tells us about this angle B down here. If we took this B and instead cut our transversal, so created a cut, and rotated this parallel line so that it sat over top of this parallel line, I think you could see that B would actually match up with this angle here. So what we end up seeing is that angles that are on alternate sides of the transversal, but contained within the parallel lines, are equal. So this angle is 55 degrees, and it's on the opposite side of the transversal to B. And so we can state that 55 degrees is equal to B because of the transverse parallel theorem alternating, because it's on the alternate side. Likewise, we can think about another situation. This 55 degrees, and in fact this whole line, could simply be translated down so that this angle would correspond with this angle in the same position as 55. I think you can see that just translating this system over top of this one would leave us with this angle C also being equal to 55 degrees. Because it corresponds to the same position. So here we can say that 55 degrees is equal to C because of transverse parallel theorem corresponding. And this is how we would show our work demonstrating our theorems that we've used. So now we can try to fill in some of the blanks. We know that C was 55. We know that B was 55. And we know that A was, looks like it's going to be 125. And that's because we would just subtract 55 from both sides to isolate A. Now we could use the opposite angle theorem to find that because 125 is across from this angle, it must be 125 degrees by the opposite angle theorem. And now notice this 125 now corresponds with this 125. And we could say that by TPT corresponding. Or we could even say that by TPT co-interior with the 55, or by supplementary angle theorem with the 55. You can actually fill out all the rest of these angles using a multitude of different theorems. easiest perhaps would just be to use opposite angle theorem and opposite angle theorem there. But also notice that 55 and 55 correspond, and 125 and 125 correspond as well. And that's the ins and outs of the transverse parallel theorem.